Can you please confirm if you can see the screen?
Yeah, we can see it.
Okay.
Yeah.
Yeah, sure. Yeah. So basically, whenever we start talking about AI, so it was actually a very huge domain actually. So there were a lot of things involved in it. So in a very high level, this is like an umbrella, whereas in this umbrella in AI, there are a lot of things which were involved. There is a data science, there is machine learning, there is something known as deep learning. So most of us guys which we are seeing now in the market, like making boom in the market, like ChatGPT, Google Gemini, all those kind of things, those were built in using this deep learning. I mean architecture of deep learning. So there are a lot of architectures actually. We'll explain about, go through that things like convolution neural networks, recurrent neural networks, generated adversarial neural networks, and transformers. This is actually the main thing, which is the premium. What is the primary thing, or the ancestor which is powering this chat gpt or google gemini and these kind of things. So on top of it, they made some changes in the architecture and they trained it on used data, and using that they are building some great models which are capable of answering whatever question we ask into every domain, not only based on one domain, into every domain: healthcare, finance, whatever question you ask, it's capable of giving. Now if we go into this hierarchy, if we go deep down into this, the first of all, we can see there is an AI. What this AI is, whenever we use our intelligence, like human uses his intelligence to do lots of tasks, right? He can go to college, understand things, and he can go to job, understand the requirements and do his job according to requirements, get a salary and feed his family and everything. There's a process that has been involved in a journey of a human. Similarly, AI is a thing which is capable of taking the human intelligence and giving it to machines. So whenever a machine possesses that kind of intelligence, it can do some crazier things. So to make systems intelligent, to build intelligent system or systems capable of performing like human tasks, to do those kind of things, this AI is used. We can call in overview that AI is capable of doing tasks which can be done by human, or at least which requires human intelligence. So there are some of the applications here when it comes to our AI. So it was used.
Sorry to interrupt you if you don't mind.
Sure, sure.
Eh, I can see if the session is recorded, so
Oh,
better if possible, can you please record, because
yeah, it is
some other
recorded. No
people
problem.
also,
It's recording. It's recording.
I informed them, so I need to share the video
Yeah,
because
it's
they didn't
recorded.
join.
It's recorded.
Yes, yes.
See, it's going on.
Yeah.
No. So
Thank you. Yeah.
you can see the screen, right? I mean, I have actually shared
Yes,
only
yes,
this
yes.
tab. Artificial
Yes.
intelligence. Can you see this?
Yeah.
Yeah.
Yes, yes.
Okay, sure.
Yeah. Okay. Yeah. Thank you.
So now going into this, as we discussed earlier, that whenever you use this intelligence and try to build some systems based on human intelligence, like how humans think, how humans work, if you kind of give this intelligence to the systems, they can do the same tasks by the human. So that's the reason why you are hearing lot of things like jobs will be taken up by AI, lot of things which are getting automated can be done by AI. Now there's a lot of difference when you do automation and when you actually do the tasks which are capable of doing it like a human. So we can understand about those intricacies the further when we are explaining about computer vision and natural language processing. For the time being, just understand AI is a very huge and vast domain where it is capable of understanding, making some intelligence or having its own intelligence and trying to perform tasks based on that intelligence like a human. That's it. And now these are some of the applications. If you go into it, natural language processing, whenever you say natural language processing, you can see language here, right? This is natural language processing. Whenever there is something known as English or Telugu or Tamil, Kannada, Italian, French, Mexican, whatever it is, so two people communicate, both people communicate. If one person knows that language, he can communicate with the other person using the same language. Let's say the common language between all of us who are having this session, me and you guys, is an English. In English, I'm telling I am explaining you the concept, and you guys are grabbing that concept because you know the English. English is the medium here through which we are communicating each other. Similarly, if I want you guys to do some task, I can communicate with you in English and you can get the task done. Similarly, if you have any doubts, you can ask me the same question and I can respond you back in English. So the way how we humans interact with each other, get the tasks done, get queries asked, all of those kind of questions. So those kind of things can be done by the systems as well using natural language processing. So in this natural language processing, there are very famous applications which you can see. The chat gpt is one of the thing, because you are a human and you are literally talking to a machine. What is that machine capable of? Machine is capable of giving you answers in English. What is the medium here? Medium is language, and that language is English. So using English language, you guys are communicating. Means we as a humans are communicating with ChatGPT, asking it lot of questions. It can be related to finance, healthcare, personal, professional, everything, and getting those answers answered by the machine. So we built those machines that are capable of generating answers that are required to a human. So it is in this stage where it is capable of understanding what human is going to ask, what human is going to give me the question, what kind of questions are human going to ask, and how can I process it, how can I respond it back with some genuine answer or at least some valid answer, rather than giving some scrappy answers which are not relevant to the topic. It is capable of giving us some great answers. So that is the level of AI we are having currently in form of chat gpts, which is completely powered in using natural language processing. We can understand about those algorithms, what algorithms are there, what are the architectures of those algorithms, how those were trained, what were the systems that were used while training, what is the infrastructure that has been used. We can go about that later, but as of now you simply understand natural language processing as a way that humans are communicating with the machines in a way that machines can understand in a language which is English as of now, while you are speaking to ChatGPT or Google Gemini, and it is processing the information given by a human and it is responding back with the valid answers what human is expecting. That is what natural language processing is. Now let's discuss about computer vision. This is another domain which is majorly dependent on image data, video data. Whenever you have some things which are completely image based and completely video based, it is capable of understanding what is the image that you have been passing it and what is the answer that I should give it. Even in chat gpt you guys can see there is a feature which is capable of taking an image. I think it is in plus version. If you can give an image to it, and there are free software as well, while they can take an image and can explain what is there in the image. Let's say I am standing in front of my home and someone is taking snap of me and uploading it in ChatGPT as an attachment. Now that image will be taken by ChatGPT and it is processes the image and then tells about that image. Like a human is standing in front of a home on a wide street with a lane. So similar, this kind of descriptions AI can give. So what is happening internally? The vision models, which is capable of understanding the image, understanding the video, and capable of giving the answer based on what objects or what things are actually present in that image. That is the domain which computer vision actually deals with. As of now, you can think natural language processing and computer vision as specialized domains where you need to have a basic understanding of how to understand the models, how to write the models, how to understand the math that is capable of writing these algorithms, which is powered by the models. And to understand that math, what are the basics we need to go? How can we make sure this math is written, math is used in the algorithms? How that algorithm is connected to the data, how the data is connected to the problem, I mean the problem data. So these kind of things we can understand more deeply as we go further. So as of now you can understand these fields as some of the specialized fields which is capable of which are mostly used in the market right now. These are very trendy in the market. So using these technologies or using these specialized domains, there are a lot of job opportunities, and we can explain about those job roles also going forward. Now, these are very specialized domains, and robotics is something which you are capable of doing it with robots. So you make a machine and you tell that machine what to do and what not to do, giving it intelligence, like Tesla bots, Nvidia bots. So recently I think you have heard about this Jensen Huang, like the Nvidia founder has been released that bots like Dali, sorry, not Dali, this Wally kind of bots, which are capable of doing some tasks that can be assisting humans in their daily activities, those kind of things. So those were something comes under more robotics using this natural language processing. This is an synergy, like where you are using this and building this an application using natural language processing for using this robotics, those kind of systems. And expert systems, recommendation engines, those are some kind of systems which are completely different and has some different set of knowledge for us. But understand, these are also systems that have some intelligence and it has some basic understanding of mathematics, how those mathematics work in building those algorithms that powers those systems. As of now, this is what this is, and these are some of the applications actually which were built using AI. Now, if you go to programming language, this is an how we can do tasks with AI. So let's say you can see you can do some of the specific tasks as well, like virtual assistants, like chat gpt and all of those chatbots, like personal assistant. You see, you guys can see Google, sorry, Apple's Siri, and Amazon's Alexa, and let's say Google Assistant. What are these things? These are nothing but assistants which takes voice as an input and get backs to us as a voice. Now this Amazon Echo as well, how this works, Alexa works, it tries to listen to you, and whenever you give a voice command, Alexa listens to it, and after Alexa listening to it, it tries to execute that command by linking itself to the devices. Let's say we have an bulb at home which is powered, which is completely connected to this tech, and then if you say something to Alexa, you just need to configure that settings of a bulb into this Alexa, into an application, and you just need to say it in a simple English: Alexa, turn on the bulb, turn off the bulb. Alexa, turn on TV. Alexa, shut down the door. Set the TV temperature to this kind of things. I think you guys are aware of these things, right? Alexa and Google Assistant. At least Alexa. Most of you guys have used it in your daily lives as well. And
Yeah.
voice commands you used in TV.
Yeah.
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 Yes, so these are some of the applications actually. These are like virtual assistants which are helping us in doing our daily tasks. Now, this is a general AI where hypothetical human-like intelligence across various tasks. Like when you say human-like intelligence, it is literally nothing but a chat GPT which is answering you with a code. Let's say if you are in office, you are struggled with a code. Let's say your manager gave you some task and you don't know how to do that task. You simply take the task and explain it to ChatGPT. Say that as a human, as if I am explaining to you. You explain to ChatGPT saying that, see, my boss has given this work. I don't know what to do. This is the code he wants me to write. He wants me to write it in Python. If you guys write it in Python, if you can write the code in Python based on the problem what my manager asked, I'll be very happy. It will give you the code of Python within seconds. Now that is what human like intelligence is. That is the reason why most of people are actually telling this might take away your jobs when you are a developer, when you are a graphic designer, when you are doing some boring kind of things. Not, I mean, I'm not criticizing or not particularly pinpointing anything here, but that might take some time as well, because we humans need to be there to analyze whether this AI is doing it rightly or not, whether it is doing in correct way or not. Because until and unless humans doesn't understand what AI is doing, literally we are in possession of an AI. So that is not happened till now, but in future, but in near future, that is very much possible that we might get completely trapped in the world of AI, and we will be listening to what AI is. But we are making sure, at least these big companies like OpenAI, Nvidia, and the pioneers in this industry, Google, Microsoft, they are making sure AI doesn't go into wrong hands, and even Meta to that matter. They are making sure whatever AI, whoever building that AI, no matter how smart it is, that needs to make sure a human should understand what it is doing, and it needs to set some ethical boundaries or some logical boundaries to it, practical boundaries. So till now AI doesn't have some sense of attachment, sense of feel, sense of touch, sense of understanding. It understand task lot. That is another thing which is known as sentient AI, where AI is capable of understanding itself and doing things on its own. Even AI can do it right now using something known as agents. There is an agent is nothing but a simple instruction which is given to perform a specific kind of task. Let's say in chat gpt, if you can go through the agents, you can see different agents. One agent is very beneficial for you to give you assistance while cooking. That can be called as a cooking agent. Let's say if you are facing problem related to driving, there will be a driving agent. Let's say if you have an problem related to making some food in your home, there is an agent who can give you recipes specifically. Now what this sentient AI or the advance or the bleeding edge, or that is not even happening now, but that might happen in future. What actually happens, this thing can make decisions on its own and can do the task on its own, and it won't even require human to go to give it a green signal whether to do it or not. But as of now, till date, to the present date, we are making AI to understand what it needs to done. We are giving or we are passing specific instructions of what it needs to done, where it needs to do, and till where it needs to do, because it shouldn't cross its boundaries. We are setting some limitations, boundaries, and we are drawing some ethical boundaries as well. So let's say if you ask some question which is not very human, let's say if you ask something related to drugs, or let's say medicine, or some things which are not accepted in our society. So with those kind of things, if AI is capable of giving you answers, then it is nothing but it is completely taking over, or it is crossing the boundary. So that is the reason why bigger companies like OpenAI, Microsoft, Google, Meta, these are placing some boundaries while or limitations, while making sure whatever questions you are being asked, those must be answered only if that falls under this specific criteria of the ethical, logical, and human level of tasks. So that's the current status and state of the art till now. And to build these kind of, this is very high level introduction of what is intelligence and all. You no need to think about that sentient AI and all. That's very advanced concepts and all. Even that is not used anywhere in the applications or this thing. That's completely in research. Now, getting back to this, we guys needs to understand any of these programming languages in order to build these kind of systems, especially Python and R. And Java, we can use Java as well. But mostly preferred language is Python here. The reason being, let's say one of our colleagues or one of our friends has started their journey from accounting right away to this data science. Now what this Python does, this Python has specific libraries. Even an accountant, even a person, or even a community from accountants has already developed based on the tasks which they are doing, and put that as a package and put it into Python. So that is the reason why even a person from accounting background can come and can learn this Python and can understand this Python and can write a code in Python in an easier way. That is one of the easiest languages right now, and you can learn it very easily. It's a simple English most of the times, and once you are aware of the syntaxes, how to write, how to go with it, that doesn't make much trouble at all. Especially now in this age of AI, where ChatGPT is giving you code and everything, literally whatever you ask for, it's not a big deal. You can learn it in no less than a month if you are very strict on learning this. But coming back to Java and R, we can use these texts, these programming languages as well. But mostly, these programming languages we need to write a lot of code, and there needs to be a lot of community around. Because in Python there is a lot of community. Whenever you are coming from accounting, mathematical background, research background, at least from sales background, whatever background you belongs to, it is as easy as a community is built around it, and you guys doesn't feel a problem or understanding the syntaxes and everything. You can guys learn it in no time. That is the reason why Python is very preferred when compared to other things. But for speaking logically, you can write using these languages as well. So that is how it is. And coming back to mathematical concepts, these are very very limited concepts which we were dealing here, and we can explain about the math going forward. Right now, understand this probability and statistics are something which you need to learn, at least have an high level understanding in order to build some predictive models. When I say predictive models, let's take an scenario. We are working, let's say we got a client who has this industry of the petroleum industry. He comes from a petroleum industry background. Let's say he wants to see what his sales are going to be next 2 to 3 years. For that, you need to have huge set of data, huge data sets, and huge corpus of data. To get that data, client needs to give you the data. You need to do some analysis, you need to do some statistics, and you need to build some algorithms which takes statistics into it and tries to tell the client, see, this is what we can do it within, this is what your business is going to look like within 2 years of time, within 1 year of time, within 3 years of time. So these statistical analysis and probability concepts will be used while building those predictive forecasting kind of models. So we can explain about, we can go deep into these kind of things later on. As of now, just understand this is very high level, we need very high level understanding and deep understanding actually of algorithms, because whenever you are working on these algorithms which are used for predictive modeling or forecasting kind of things, you need to have understanding of how that algorithm is written, what is the math under that algorithm. It's not, because if you want to use that algorithm, it doesn't take you a minute, because the library is already available, the packages are already available from matplotlib. You can simply take that library, you can make it work, you can train the model on the data, and you can use that model right away. But how that model is working, why that model is working, if something is not working, let's say if the data is not getting understood by the model, you need to understand why it is not getting understood, whether it has been done, that whether the training has been done properly or not, whether the data has been fed properly or not, where exactly the mistake is happening and all. So for that, you need to have an understanding of algorithm, because if you don't understand how that algorithm works, you doesn't understand how can you solve that problem using this algorithm. So that is the reason why and that algorithm is heavily dependent on mathematics, because there are specific algorithms which are completely dependent on mathematics, like statistics, probability, and linear algebra, like linear regression, logistic regression. Let's say if you talk about naive Bayes, that is completely built on something with probability. So these are some of the algorithms, and these are some of the mathematical concepts which you need to build those algorithms. So don't get overwhelmed here. If we have very basic high level understanding of those mathematics as well, we can go and we can build those models. And rest of the things, ChatGPT is there for our rescue. It can answer you whatever you want. But understanding this with an deeper level of mathematical intuition is one thing which we need to focus on to understand that algorithm deeply while working with the problem. Now these are some of the job roles, and just ignore these things. These are some of the job roles, and we can discuss about each and every job role based on the domain which you are taking more deeper going further. Now in the data science, this is one of the another realm where you guys completely focuses on right from collecting data to right from deploying that model on that problem. For example, let's say if your client gave you a problem statement of building a chatbot, right from collecting the data, and the chatbot is from, let's say, from healthcare, you want to build a healthcare chatbot. So what this data science involves, this data science involves all the phases that are necessary to build a chatbot, right from collecting the data of the healthcare from the client to process cleaning the data. Because the data has lots of let's say if you are dealing with image data, you can be dealing with text data, you can be dealing with audio data as well. So for that thing, you need to clean that data. That is where the data cleaning phase comes into picture. See, this is process of data collection, and in data cleaning, you need to clean the data of a chatbot. I mean, for example, to build a chatbot, that healthcare data which we are taking from the client, we need to clean the data. Let's say you are dealing with image data. Even in those images, you need to make sure those images were trained on the model using something known as augmentation. For that augmentation, what you need to do, you need to clone the data, you need to process the data, you need to make sure the data is repeated, and it needs to capture each and every feature differently. So that is one of the thing when you are dealing with data, especially on images. If you are dealing with data, especially on text, Let's say what is text. If you are building an application which is completely focused on text, like ChatGPT kind of things, where you are asking a question in text, you are getting a response in text. In that kind of data, if you have a data to build that healthcare chatbot using only text data, in that you need to use text data. Like in text cleaning, what you have, let's say you have an conversations of people speaking to their customer care of that healthcare company, and those text will be those voice will be recorded and converted into text and given to you to train a chatbot. At that time you need to process that text, you need to clean the text. What do you mean by cleaning the text? Let's say in the text there are full stops, exclamatories, inverted commas, lot of those things. Let's say that text is not aligned, it is not in proper format, those kind of things. So that is where the data cleaning comes into picture, to clean any type of data. It might be text data, it can be image data, it can be video data, it can be audio data. Now this is the data cleaning. And data processing, you need to understand, you need to process after the cleaning. Once the data has been cleaned, you got a clean data, you got a text which is capable of which is very clean. All the exclamatories, full stops, question marks were removed, and all the unused information, useless information has been removed from the text. And then you have been went into data processing, in which you guys are completely focusing on how to process this data. Like this is in a phase where you can work with the data to get some insights. This is where the EDA comes into picture. You guys are going to do some data analysis on it using data modeling, data visualization. So in data modeling, what this exploratory data analysis is something where, let's say you are having the chatbot only, for example. Let's say in this chatbot, if you want to analyze, if you want to go deep into building those chatbots, even those chatbots, let's say your client asks you to give some insights from it as well. Let's say you want to understand that chatbot from the textual basis, from the text data, and you come to conclusion saying that people who are reaching this chatbot from 7 to people who have people, let's say, who are having conversations with customer care representative in these aspects, let's say regarding billing or regarding booking consultation, these kind of topics are having very high weightage. So what this exploratory data analysis does, it gives you tools which can help you to get those kind of insights, where you can understand that these people are actually speaking to customer care representative regarding booking, or people are speaking to customer care representative regarding these things. So those textual information data, if you want to understand more deeply, out of 100% of data, where this data is actually splitted into or segregated into. So these things, these exploratory data analysis give you tools to understand those kind of data and give you insights to those specific kind of data. You guys needs to do this EDA on the data to get more insights. And after that, once the exploratory data analysis has been done, you have got some insights into it, you got some patterns, you got some understanding of the data. Now you guys want to train the model based on the problem statement. Now our problem statement is, let's say if you want to train this healthcare chatbot in answering the questions asked by a user. Now what we are going to do, we are going to simply build a model which is capable of understanding question from a user, and we already have a data, right? Whatever users have been asked previously. So those kind of questions we are taking and training the model here. Here we are training the model, and we are giving these patterns and insights to the model and telling the model, see, these are the kind of questions which our customers have asked us previously. Now in future, let's say if our questions, if our customers asks these kind of questions, you need to answer in this way. That is how you guys are going to train these models, by telling them the instructions of how the data will be trained based by doing all of these steps. So this is the phases. After that, you guys are going to do evaluation. Once the model has been done, you have trained a model, you guys need to test the model. You need to check how exactly that model is performing, whether it is performing according to you or not. Whether, let's say, if a question is asked by a customer, or customer in the sense the person who is consulting this healthcare chatbot, whether the chatbot is answering in a proper way, whether it is not answering in a proper way. Let's say he asked a question saying something, I need to do some booking with Dr. XYZ. Let's say our chatbot responds, we have this medicine available in our store, please contact this section to buy this. This is completely irrelevant answer, right? So for this thing, what we are doing, we are making sure that model which got trained, it should be capable of giving answers what user expects, not the other way around. So that is the evaluation happening. So this is evaluation actually takes care of understanding whether the model has been trained properly on the data, whether it has not been trained properly on the data. If not trained, why it is not trained? If trained, what are the things that we need to take care of in future? Those kind of things. Now getting back to data visualization, it is nothing but whatever you have built the models, whatever the analysis you have been doing till now, you guys are simply portraying those analysis using this data visualization. Model deployment, simply think you build these crazy models which are capable of answering the questions of users. You guys just need to deploy. You guys deploy on any of that stack, GCP, Azure, or AWS, and that is how it works. Monitoring is nothing but making sure the model works as expected. Let's say if a model is not working as expected, then it is going to be a problem, because no one likes to take an application which is not working, right? So you need to make sure whether the model is working fine or not. That is how the monitoring works here. Now even the programming languages are same here. So our preferred language will be Python. Mathematical concepts, so just understand these are some of the mathematical concepts those are involved, and it completely changes based on the problem statement which you guys are going to have. And these are some of the job roles, and we are going to have a deep dive into these job roles as well. Now getting back to this machine learning. Machine learning is a system that is capable of using and building the model in the phase of where is this data modeling. So in the data science, there is something known as data modeling. So this data science actually 5 steps. Let's say data collection, let's say you can expand it as well, data cleaning, data processing, I mean EDA kind of thing, in the data modeling, model evaluation, and model deployment. So these 5 stages you can think of in a very high level, broad level. So in this level, data modeling, what it is doing, we are training the models. We are making sure the model has been trained on the data which client has given to us. That thing will be taken care in the machine learning, where mostly that enables systems to learn from data, where you are training the model, improving the performance, and trying to make sure that model has been learned and performing based on what the data have given to it. And again, there are types of ML here. There are 3 types on a very high level. Supervised learning, it is something that we have been taking the training data, training the model on that data, and telling the model what it needs to be done. That is how the supervised learning. Supervisor, even you guys can understand, supervisor is someone who actually supervises the work. Let's say we have a manager in our company. What does our higher manager does? He keeps tracks of all of us, whether we are doing work or not, whether we are doing work in a right way or not, whether we are wasting our time or not. So this is the supervised learning. Whereas in this supervised learning, we are telling machine learning models what to do, what not to do, and what data to train on, and what are the expected outcomes from that data trained on that model. So that is how the supervised learning works. We need to supervise each and every time in each and every phase while building those models. So completely, what does that mean by supervised? You are explaining the model by giving them the labeled data. What do you mean by labeled data? Let's say you want to build a machine which is capable of understanding to detect whether it is an cat or a dog by showing it an image. So you need to train the model by giving it set examples of cats and examples of dogs using a label data, saying that you have a cat with 4 legs, and say it is a cat, it is a fluffy cat, or it is an skinny cat, it is an separate breed of cat, those kind of things. That is what label data means. So this is how you can give the data labeling the data and give it to model and supervise it. How? After training this, you are supervising whether after giving this, let's say you train the model on 100 images, 10,000 images, or 1 lakh images based on the data you are giving to model, and after that you are asking the model whether that has been detected properly or not. Let's say you give a new image which the model has not seen, and you ask it whether this is cat or a dog by showing, let's say you give it an image of an cucumber and ask it what is it. If it says it as a cat or a dog, then that simply means that your model is flawed. So that is why you need to supervise it. If you know that model is flawed, what you are going to do, you are making sure that data is in a proper way. Whatever data you are giving, the data can be cleaned and proper data can be given. So that is how it works, the supervised learning. You are supervising in each and every phase and making sure once the model has been done, till then you are training it, testing it, training it, testing it, then cycle repeats. Now getting back to unsupervised learning, this is something which This is something which we do when we don't have any information about data, and yet we are trying to find something from the data. Let's say there is a medical let's say there is a pharmaceutical company, or let's say there is a research in medical industry, healthcare, which are who are trying to build a model that understand the images of scans and trying to detect whether a person is having a disease or not. So to build those kind of models, you need to have a proper understanding of what is a disease, why does this disease occurs in the first place, what are the diagnosis of a disease, how to identify this disease. So let's say if you don't have any understanding of these kind of diseases, even for that say corona as well, so for those things you are simply passing the data of medical images or whatever the medical data it is to these models, which are trained on unsupervised learning, and asking it find some patterns in this data, because there are no labels on it. That scans doesn't say this person is diagnosed, or this person is having this disease or not having this disease. He simply passes the data and tells it to identify some patterns, and based on that patterns we try to analyze, okay, this is the pattern due to which this is occurring, this is the pattern due to which this health condition arises. So based on that we can take some decisions. Unsupervised learning is something where we don't have any knowledge about the data, and we simply passes the data to the model. Model is capable of finding out some patterns or some understandings or insights from the data and getting back to us with those insights, and from that we are making some assumptions on that data. That is how it works. And clustering and dimensionality reduction are some of the topics which were techniques which were used to build these kind of models, unsupervised learning models. And reinforcement learning is something where model is capable of learning on its own based on the mistakes it has done previously. Let's say if you have played if you listen of this alpha fold, or let's say you see this chess player, automatically you see an AI which is defeating these chess players who are top notch chess players as well. Or let's say there is some model which I don't remember, alpha fold or alpha something, which actually defeated AlphaGo, it seems. Yeah, AlphaGo. That AlphaGo model actually defeated some players who are very good in that model. So basically, that is a game playing model where there is a game known as Go or something. That game has certain rules, and what this scientist did, this scientist trained the model, saying that they have trained the model. They simply told, see, this is the destination, or this is how you need to win. You need to capture your enemy by doing these kind of steps. Once you take all of his coins, once you defeats him, once you takes off all of his coins, then simply you defeats him and you won the game. Let's say these are some of the instructions. Now what this reinforcement learning tries to do, it tries to understand ways by thinking on its own, how to go, how not to go, which step to take, which step not to take, and whom to kill, whom not to kill, based on how the game progresses. In chess, as you guys know, there are lot of moves, right? How many guys of you know chess here? Anyone knows chess?
Yeah.
Yeah. So in chess, mostly it depend. We don't know what is the move that is going to make by our opponent, right? So what usually
Yes.
happens, we need to adapt based on the moves that our opponent going to play on us. So based on that, what we do, we are trying to strategize ourselves in such a way to defeat our opponent in a very strategic way. So that kind of strategy has been learned by the model using this reinforcement learning based on the mistakes which he did on the past. Because you don't have any data to train with, right? Because as a human, while we are playing with someone, some random human, we don't know how to play the chess. Let's say we don't know how to play chess, we simply make mistakes, and we don't know rules, we simply make fuss of it, we mess up there. Let's say if you know some rules, you try to play it, you try to win. Because if you don't have experience, if you don't have strategy, you can't win. So over the period of time, you guys learn how to make moves, how to tackle, how to strategize, and how to win the game. In a similar way, this reinforcement learning tries to understand the moves by adapting itself to the conditions and making sure it learned that conditions somewhere in the future, somewhere in the past, and based on those experiences, it tries to go forward adapting that. This reinforcement learning completely works on adaptability. There is something known as action, reward, those kind of things which we don't want to go now, at least. So I'm giving you a very high level overview. It is something which is completely based on reward based system. Let's say if you give a reward to your cat saying that if you catch the mouse you are going to have some good food, then that cat is going to catch the mouse all the time. That is how we are going to make sure that cat gets to its food. If the cat doesn't catches the mouse, then it is not going to get a food. So in this way, we are going to give a reward to make sure this perform this task. In our case, reinforcement learning, how it works, we are making sure until it wins, it is not going to have any reward. So it needs to make sure it wins. How it wins? It needs to strategize, it needs to learn the strategy, learns the adaptability, learns the tricks on its own based on the experiences. That is how the reinforcement learning works. So these are some of the high level concepts of what actually machine learning contains. And industry most of the times, even if you want to, this completely depends on use cases of our clients, use cases of our companies where we go for. And some of our clients are completely focused on supervised learning, where we need not to do much with unsupervised learning. We just need to train the data, focus on the data, make sure that data has been trained properly by the model, and once he gets what he is expecting, then client will be satisfied. So we need to make sure at least we were in that position to make sure the data we are going to train and the model we are going to train is in a proper order. Whether it is getting the answer what the client is expecting or not, whether it is getting the outcome what we are expecting or not, is the major point which we need to focus on. If we got that, then we are good to go. This is how supervised learning, unsupervised learning, reinforcement learning works. And these are some of the important concepts. Don't go into it, we can go it much deeper while we are working on a real world project. Feature engineering is something where we are completely focused on a specific feature. Let's say you are building a home. To build a home you need to have some the foundations as well, right? The cement, the sand, the bricks, the mortar, those kind of things. So feature engineering depends on each and every component. Let's say bricks, how are those bricks designed, what should be the dimension of brick, where should these bricks be laid, those kind of things. You need to go deeper into each and every feature of those kind of things. That is what feature engineering is. Overfitting is underfitting. These are some of the concepts which we can go further. Just focus on very high level overview of how these things work now. And again, programming languages, when it comes to it, Python, R or programming language, again recommended is Python. And mathematical concepts, linear algebra, calculus, probability statistics, optimizations, or something which we need to learn to build. And again, this completely depends on use cases and job roles. Again, don't focus much on it, we can focus on further. Now getting back to deep learning. Deep learning is a phase, or deep learning is a specialization where you guys needs to focus, or where we are building some advanced algorithms or building some advanced models which are capable of understanding the images, text, audio, video, whatever, even the code as well. For that point, if you are capable of if these complex systems are capable of understanding it like a human and processing that like a human, or as like a human brain, and giving you answers like a human, then simply you can do it using this machine learning, using this advanced domain or advanced specialization. So in deep learning, what is actually happening, you are dealing with something known as deep neural networks. So simply understand it like a human who is trying to process something in his brain. Let's say if you want to get something from the market, supermarket, how can you go and get that from the supermarket? Let's say you don't have any supermarket in your place. How are you going to do that? Any of you, can you give me example? Let's say you want to buy some eggs or some meat or some groceries for your home. If you want to go to supermarket, let's say no supermarket is available, how can you find out those items? Can you guys give an example? Anyone, please.
Maybe we can search for supermarkets in Google. Otherwise, we need to book
Let's say you don't have Google available with you. Let's say you don't have technology itself.
Then it's difficult. We need to roam around, and we need to roam around, and we need to find the shops.
Yes, exactly. So what you are actually doing, you are trying to figure out how can you do this, and your brain instructs you saying that okay, go to Google and try to search in Google. You guys can get some nearby supermarkets and go to that supermarket and find it. If it is not available, go to other supermarket, use Uber to go, all of those things, right? You are laying out a structure, you are laying out a step by step process of how can you go to supermarket, get those things and get back to it and get the work done. Now what is your actual problem here? Your actual problem is to make some food which needs groceries. For these groceries you need to go to supermarket. For going to supermarket you need to work. So in this all the in high level process of it, your brain is completely involved in thinking how can I make this food using different elements or using different prospects. Those are already available with me. Like you used technology, you used automobile to go to market, and you used your payment gateways like Apple Pay or something, you to go purchase those groceries and come back to it and went. So your brain played a very important role in understanding each and every concept and getting back to you, getting your task done. That is how our brain works, right? Similarly, if you want to, even if you want chat gpt to give you answers of what you expect, those are also having brains. Understand those brains are nothing but neural networks, how our brain has been designed. Similarly, that brains of those neural networks, I mean using these neural networks, the brains of those machines also designed in such a way, it should understand the concept, it should understand the problem, it should understand the situation, and based on that it should revert back to you with a proper response. To understand that concepts in much deeper level, what is happening, the way your brain works, like a neurons are capable of understanding the information, storing the information, processing the information by triggering and by sending it to another neuron. Based on that you are processing the action and you are going out, you are getting the things done and getting back to home. Similarly here, neural networks are something which are playing that kind of role. What neural networks are doing, neural networks are capable of understanding the data which you are giving. Let's say you have a problem of going to supermarket, like you are asking the machine to go to supermarket and get some groceries for you. What you need to train this neural network on, what you need to build an artificial brain on, you need to create an artificial brain which is capable of understanding what is a supermarket, what is an society, what where how can you go into this society. Like you can find lot of people, you need to say hi, bye. If you can find some people in your journey while you are traveling, let's say you can't say hi, they might feel that you are a bad person, you are not responding back to them. So there are some social aspects as well while you are going to supermarket. Now if you are building the same kind of thing using the machine, you are processing this, you are telling the same instructions to the machine or to a chatbot or to a bot or to any machine, you need to make sure each and every aspect is understood by that machine. How you are going to do that, how that information has been stored by the machine, using this concept known as neural networks. It processes the information, understand the information, store the information, and transfer the information to other layers. Similarly, how our brain is connected with multiple layers, even these have deep networks. That means 3 layers these networks are having. Artificial neural networks, you guys call this as artificial neural networks. So what this artificial neural networks does, you simply understand this is nothing but a brain, like a human how he is doing things, a machine how it tries to do things in this way. This neural networks is nothing but a brain like structure for computers or for robots or for some machines, in order to make sure they can understand the task by processing it, understanding it, storing it. So this is nothing but artificial neural networks. So this is artificial. Why it is artificial? It is storing the data which you are giving artificially. Neural networks, why you are giving that name? Because as human how you are storing your information in your neural network, that is the similar way this is also storing the information using this neural networks. This is very high level understanding of how machines understand, process, gets the tasks done by using this artificial neural networks. Now understand this as a vanilla flavor of an ice cream. Whenever you are having an ice cream, everyone is not interested in vanilla flavor, right? That is a very beginner flavor. If you can understand there is an ice cream, you can understand okay, this is a very basic level of ice cream where it doesn't have any flavor. Okay, this is an ice cream, that's it. If you want to have very customized level, or if you want to have very everyone has their own specialty, everyone has their own flavors, right? So if you want to go deeper into their flavors, so those kind of flavors like strawberry, chocolate, let's say pineapple, butterscotch, all of those kind of things. For those kind of layers, simply understand there are different concepts such as natural language processing, computer vision. Let's say someone wants to work only on text data, then using these neural networks they can work only on text data. If they works only on text data, that is nothing but natural language processing. You have a domain there. If someone only wants to work only on image data, or let's say works only on video data, then that is nothing but you guys are simply working on something known as computer vision. This is nothing but CV. So if you work on this data, this is let's say another flavor, flavor too. Let's say pineapple or chocolate flavor or ice cream. And this ANN is nothing but a very basic flavor. At least to get to know there are these kind of ice creams. Let's say this is an vanilla flavor. This is what you know. Okay, these are the things available in the market. Now if you want to do specific kind of flavor, let's say text, you want to play with text based information, natural language processing you can do, and there are specific neural networks for building these things. That is nothing but RNN, recurrent neural networks. So these neural networks are capable of understanding the data which is in form of text and trying to process it and giving you the response. And image, video, those kind of things, there is something known as convolution neural networks, CNNs. So these models are capable of understanding the data which is in text, or building the algorithms which are capable of understanding the image and telling that okay, this image is that, this image is this is a cat, this is a dog. To train these kind of models in computer vision domain, you need to understand convolution neural networks, which is completely based on image and video data. So for these things to understand, you guys need to have high level understanding of neural networks. For these neural networks to understand, you need to understand how your brain works. So no one understands how our brain works, right? Because there are a lot of computation that our brain does. Even a human can't understand how does this brain works. What is an IQ? How does that IQ depend? So there's a very limited understanding. But whatever information is available to human, based on that we try to prepare something using this RNN, using text, used CNN for image and video data, and those kind of things we have prepared on based on our requirements. That is how the advancements of deep learning and CNNs has been done. These are the key concepts. So as I told you, neural networks are something like human brain how works. Activations or functions are something that tells us okay, this is the right thing to do, this is not the right thing to do. Let's say you need to identify him as a friend. Let's say we guys connected with each other. Let's say on the second meeting, some of you guys can remember my name, or some of you guys can forget my name based on your memory power. Let's say in third meeting or fourth meeting, it is highly possible that most of you guys can remember my name. So how is it happening? Your brain is processing internally, okay, this is how it works, this is how I need to understand this is how I need to process the information. Okay, this is the name of this guy. Based on this explanation, I can understand, okay, this is Usman. Based on his features, I can understand, okay, this is Usman. Everyone has their own way of remembering, right? So even the activation functions work in that way. These activation functions work on based on which feature I need to identify that thing. So this is how, you understand it in a very high level. How you guys understand using your brain, what is the function it is happening in your brain. This is one of the functioning happening in artificial brain while building those artificial neural networks, in remembering the task which you are giving while getting the output. Understand in that way. Back propagation, this is a technique to understand whether the task has been done rightly or not. Gradient descent, this is a crucial algorithm which is heavily dependent on mathematics, where you guys needs to understand about the differentiation, where this is highlighting this back propagation. Gradient descent is used in back propagation to build those kind of neural networks. The technique which is used in neural networks to remember, to go for back and forth to understand what it is saying, that is nothing but gradient descent. That is nothing but back propagation, which is having gradient descent in it. And regularization, hyperparameter tuning, we can go about these things in future. Again, the programming languages, high level Python and all, and mathematics, these are some of the mathematical concepts. Convolution neural networks, again I told you, if you are dealing with image processing task, there is something known as convolution neural networks. Recurrent neural networks are something if you are dealing with time series data or text data. Generated adversarial networks, if you want to generate some new samples. Let's say there is a face morphing software. Let's say I am teaching you this. Let's say someone mimics me and put their face on top of my face, and then they can say that okay, this is what they have, this is what he is. Let's say even my voice got modulated, my voice got changed, and my video got changed. Let's say Venkat here uses his face and train a model, put his face on top of my face, and tells that I am the one who explained this concept. People believe him easily because that is how this you can train a model, and this is how you can use generative adversarial neural networks for building those kind of softwares, face morphing, those kind of softwares. And getting back to transformers, these are some of the tasks, or sorry, these are some of the models, architectures you can say, in building chat gpt, Gemini, those kind of things. Again, real world applications, you can build some chatbots, you can build some sentiment analysis, real world translation. Let's say I'm let's say I'm speaking to you in English. Let's say some of our friends doesn't understand English, they want to listen in Italian. Right away in the real time the voice can be changed to Italian on the go. So whatever you are hearing, the rest of you guys are hearing in English, one of our colleague can hear in Italian in the real time. That is how the translation works. Real time translation. We can do it using NLP, and the computer vision, face recognition, image classification, all of those kinds can be done with computer vision. Reinforcement learning. Again, I told you about that AlphaGo thing, right? Those things we can do that application with reinforcement learning. Again, these are some of the deep learning models, high level models, which are architectures actually, which are powering these models. And roles, these are some of the roles. Now yeah, I think I have given you very high level understanding. Now let's get back to the roles actually, or yeah, let's give you a high level analogy of what is AI, what is data science, and everything. Let's understand, you are a chef. AI is like a chef. He's responsible for creating a dish, and this might be a very high level overview. Don't go very deeply into it because there are very nuances and very intricacies involved in it. But for understanding purpose, in high level, understand this. So you are like a chef trying to build some trying to create some dish, or cook some dish for your friends and family. Let's say data science is like a grocery store where you guys needs to go, and you guys needs to collect the ingredients and preparation methods, and after that you guys need to get the ingredients, right? So you are doing shopping here. You are doing shopping from the grocery store. You want some pulses, you want some flour, sauces, pasta, all of those things. You can go to grocery store, you can get it. This is like a data collection, is like collecting the groceries from the grocery store. Data processing something, once you have got that rice flour, pasta and everything, you guys will clean it, you guys will make sure that it is edible for cooking. So you guys make sure that in the data processing. And in a data exploration, what you guys are doing, once you have been done, you are just testing whether there is any faulty things or not, what are useful things and what are useless. Let's say you don't need, you bought milk also with you. You remember, you understand that milk is not at all used in building something, in cooking something such as semi, let's say, what do you call this thing, payasam, something, let's say, like that. What you guys can do, okay, you guys can say, okay, this is I have already bought a flour also with me. That flour is not useful in building something known as payasam. What you guys can do, okay, this is not useful, and you guys can make sure, okay, whatever things are not useful you won't be used, and whatever you bought with you, those you have cooked it and you tasted it here. This is what the data exploration thing is. Now data modeling, this is where the actual cooking starts, and you need to cook it. You need to use machine learning models. You guys can use deep learning models for building this kind of task things, because there are simple dishes and complex dishes as well, right? Someone thinks biryani is easy, someone thinks Maggi is easy. Machine learning is like building Maggi with some basic things, and for building some biryani and all, he needs to go to deep learning. This is very high level understand, please go don't go deep into it. Just for understanding purpose I am telling it. Model evaluation is something, once everything has been done, you are just testing it whether it has been tasting properly, or there is more salt, there is less salt, kind of thing. This is something you are serving it to your people. And this is feedback, is something where you are getting a review how the dish has been done, whether it is properly or not. Let's say you are going and presenting it to your client. This is what the feedback you are getting it from the client. This is a very high level analogy of how this thing works.